In this video, we're going to look at finding the coordinates of the vertex and the zeros of a parabola using the completing the squares method. So let's have a look at this example. Find the coordinates of the vertex and the zeros of the parabola given by the function y equals 2x squared plus 8x minus 3. Now, I did mention earlier that we're going to use the completing the squares method. And completing the squares is far easier on a monic quadratic than one that is non-monic. So what we're going to do, let's turn it into something that looks monic at least by factorizing out the 2. So this is the coefficient of the x squared. So taking 2 out as a common factor, I'm just going to factorize the 2 out of the first 2 terms. So factorizing out the 2, that leaves us x squared plus 4x. Okay. Now I'm going to basically just leave a bit of a space there and then minus 3. So notice that the constant term here, I've just left it alone. Now, we're going to complete the square on what's inside the brackets there. Okay, so again, on a monic quadratic, and you might have hopefully seen one of my previous videos, but if you know how to complete the square on a monic quadratic, you halve the middle term and then square it. So half of 4, 2 squared is 4. So what we're going to do is we're going to add 4. I'm going to do this in a different color, so it makes it easier to see. So we're going to add a 4 there. Okay, now 2 times 4 is 8. So we need to subtract 8 on the outside. Now what we can do is express what we've just come up with in basically perfect square form. So we can in fact factorize now what's in the brackets. So that's going to be 2 outside of x plus 2 all squared minus 11. Now, from that, we can read the vertex of this parabola. So the coordinates of the vertex x equals negative 2. So this plus 2 here, that shifts the parabola basically 2 units to the left-hand side. So another way to think of it is that a standard parabola, this is y equals x squared, the vertex is on the origin. So when we plus 2 to the x, basically the x has to sort of compensate for that by subtracting 2, because it's like as if the parabola wants to go back to the origin. That's sort of what it likes to do. So let's make x equal negative 2, and that sort of tricks the parabola or fools it into thinking that it's at the origin when it's actually not. We know this. The negative 11, so that's going to be the y coordinate of the vertex. So you can see that's very easy to then read the coordinates of the vertex from a completed square form of the equation of a parabola. Now let's find the zeros. Okay, so what we're going to do is we're going to let y equal 0 to find the zeros, or the roots. So sometimes I use the word roots and zeros interchangeably. The zeros sort of refers to the graph, the roots kind of refers to the algebra version of that. Okay, but we can sort of use them interchangeably for now. All right, so let y equal 0 to find the zeros. So in other words, so take this equation here, 2 outside of x plus 2 all squared minus 11 equals 0. Move the 11 over, and we're going to divide by 2 at the same time, so we can sort of do 2 things at once here. Okay, is equal to 11 over 2. Okay. Take the square root of both sides. Okay, so we have x plus 2 is equal to plus minus square root of 11 over square root of 2. Okay, finally, subtract 2 from both sides. So x is equal to negative 2. Okay. Plus or minus root 11 over root 2. Okay. Now, we probably should clean up this answer a little bit and sort of rationalize the denominator there. So let's fix that up. In fact, I'll do that in a different color just so you can see that at this point it is the correct answer, but let's just express the answer in sort of a nice rational denominator. Okay, so that's going to be negative 2 root 2 on root 2. Okay, and that's plus or minus root 11 on root 2. Okay, so I might just show sort of an extra step here. All right, and that's going to be equal to negative 2 root 2 plus or minus root 11 over root 2. And if we multiply top and bottom by root 2, okay, we've rationalized the denominator. Okay, so in fact, what I might do, run out of space on this board. In fact, I'll just grab another board to complete that on. So that's that. Hopefully you've got a bit of extra space there. Yep. Okay, so negative 2 root 2 plus or minus root 11 over root 2 multiplied by root 2 on root 2. Okay, and that gives us negative 2 root 2. Multiply that by root 2. Okay, so that's going to be negative 4 plus or minus the square root of 22 over 2. So therefore, the zeros are, okay, x equals negative 4 minus root 22 on 2, and negative 4 plus root 22 on 2.